is the wheel translation in vertical direction. Okay, so we'll just explore all the other force elements in detail now. Okay, so coming on to the first parameter, that is control unit. Okay, so control unit in suspensions is basically used to parameterize active suspension systems, which is a case which is like it's more related to the commercial vehicle space. So as in IP in Baha, we don't use active suspension system. So the teams can just select this as not specified. Going on to spring. So in this like spring tab, you can model the spring behavior on the front and the rear axle using different models. Okay, I'll just so I'll just show you the different types of models that are available. So there is the hook and spring model, so which is available in IPG carmaker by default. Or if you want to um, add your own model, you can do it using add model, and you can do it via MATLAB Simulink plugin or C code plugin. Okay. So just go to reference manual, see the hook and spring model. Okay, so this is the hook and spring model. So in this, you can see like how this the spring is connected to your wheel. So in this, again, the TZ is your uh, wheel translation or wheel travel, and X is your is the current length of the spring, and X naught is the unstretched length of the spring. So I earlier mentioned, so the thing that, yeah, so length IO. So you can parameterize this using you can parameterize the unstretched length of the unmounted spring using this. So I hope that it is much more clearer than before, which we had seen in engine mount. Okay. So coming on to the, like, now that we have selected the model as hook and spring model. Okay. So in this, there are various modes which are used to model the stiffness. So which are characteristic value and one-day lookup table. So characteristic value is a mode in which you will need to just add a single stiffness value in Newton per meter. So, and that will be applicable for your spring, which will define your stiffness. Again, you can use the amplification factors to uh, multiply the stiffness as well, as and when required. So, and I have also explored the length I option. So right now we'll just unclick this option, and I'll just also show you the one-day lookup table mode. So in this, so there is a difference. So basically you can add the force versus compression and parameterize the stiffness according to that. Okay, so just ensure that you are adding the compression in meters and not mm. Okay. Yeah. So now, like, coming on to this, so like, for example, so just coming on to the amplification factor once again. So just consider the thing that like, as I mentioned, so like IPG car maker can be extremely useful for the teams to simulate their vehicles as well, simulate their vehicles and optimize their testing cycles. Okay, so for example, if you're designing springs, and in that like, you can iterate between different stiffnesses of the spring using the amplification factor, and then based upon that, you can decide which type of which spring with which stiffness will go onto the vehicle. So you can get a you can interpolate these results based upon this model. Okay. So for this, you need to ensure that this model is as close to accurate as possible. So you can't just put in random values and then expect that you'll get accurate results, and just hope that the testing cycles will get optimized. So just ensure that you put in accurate models, accurate values, and this is the way you can actually use IPG carmaker to improve your testing cycle and also optimize your time, basically, which is extremely critical right now. Okay, so as I mentioned, so there are two types of damper systems that are available in that are normally used, which is the pneumatic dampers as well as the coilover dampers. So basically, like for pneumatic dampers, you can model the behavior of the air using this tab. So you just need to ensure input those values. So these values, in case of pneumatic dampers, will be provided by the OEM manufacturer only. So you'll need to do the same for the front as well as rear axle. Going on to the parasitic effects. So parasitic effects is basically like it has two parts. So parasitic friction and parasitic stiffness. Okay, so parasitic stiffness effects can occur due to suspension bushing preload. So basically, everyone like who has manufactured a vehicle and assembled various suspension components on the vehicle will know that there is a preload that is always been given to the bushings, okay, while assembly. So you can model those using parasitic stiffness, and parasitic friction can be used to model the residual friction of the suspension internal components. Okay, so for this you can there are two things that are available, so stiffness and friction. So in stiffness, again the Hookean spring model is available, and you can also add your own model if required. So in this also, like you have two options to specify the stiffness, that is characteristic value and 1D lookup table. In friction, you'll need to either add a model, or you'll need to parameterize this. So right now, I'm just going to keep it as not specified. Same thing can be done for both the rear and front axles. Coming on to damper. So uh, for damper, like there are models that are available in IPG carmaker, which are Newtonian damper and Newtonian damper plus top mount. So let's just explore this. The reference manual. Okay. So the Newtonian damper model. Okay. So basically, in this, you can see that there is this damper, and it is the force Fz is translated along the direction of damper, which is the F damp, and the length of the damper is x, and its velocity is x, the derivative of x. Okay, so and Tz is the wheel travel over here. So you can refer the reference manual and you can understand what physics is going behind the damper models using reference manual. Just go back to UI. Yeah. So in this, besides the Newtonian damper model, you will also have the Newtonian damper plus top mount model. Okay. That also. Okay. So in this, you can see that there is a combination of a damper element and a spring element that has been added on the top of the your damper. So you can simulate uh, you can simulate the properties of the mounts, elastic properties of the mounts using this. So it is similar, like the forces that are created are similar. So you can see the this diagram, and you can refer this theory to understand, to get much more understanding regarding this. Yeah. In this, so like as you know, so in damping there are two modes. So like basically the extension and the compression. So you can model this using push and pull characteristics of damping, and in that you can either do it using a characteristic value, just a single value of 1D lookup table. So yeah, and also you can, if you're selecting, so as I have selected the top mount over here, so you'll also need to add the parameters regarding that over here. So in this, like one thing that I like to mention is that like to increase the accuracy or the resolution of your model, you can just increase the number of parameters that are that you are adding over here. Okay, so basically the more number of entries there are, so the resolution will get increased. Similarly, you can also model the rear axle as well. So going on to buffer.
Yes, so addressing one of the questions we have received. So regarding the amplification value, so the amplification value is just a scaling factor or a multiplying factor which you can use while you're tuning when you're tuning your vehicle in the software. So if you can go to the damper section, Ruturar.
Just a minute.
Yeah. So while like if you are using a simple single characteristic value, so multiplying by a amplification factor, not let's say if your damper like characteristic value is let's say 1000, and if you're while you're testing, if you're checking with 1.5 2, so if you're now it is if your amplification value is now 2, so the net damping characteristic value would be 2000 Newton second per meter. So it is just a multiplying factor. Similarly, for if you're using the 1D lookup table, each of the values will be multiplied by the amplification factor. So you can use this while you are tuning your vehicle, but this is a strong note that while your final submission, just make sure that every other parameter, like all the other values are have been parameterized accurately in your 1D lookup table, and the amplification value is set to 1. Okay. Yes, we can move ahead, Rudrash.
Okay. So moving on to buffer. Yeah. So the buffers are used to limit the wheel travel in one direction or in both up and down directions in commercial vehicles. So if, like for example, if the wheel traveled far enough to hit one of the buffers, the buffer acts like an additional spring. Okay. So since Baha vehicles don't use this, so you can set the amplification value over here as 0, which will nullify its effect on the model. Okay. So but before going to that, I'll just explore let's explore this buffer for a minute. Okay. So as I said, so like this is the buffer push and buffer pull elements. So like you can understand, so for example, as I mentioned, so if the wheel travel goes above this dotted center line, so what will happen is that the will push the wheel in the downward direction. So it will act as a spring and it will push the this wheel in the opposite direction. So but as this is not used in Baha vehicle, so it is okay to set its amplification value as 0. Okay, so let's set it as 0. So coming on to stabilizer. So stabilizer is like commonly known as the anti-roll bar. Okay, so uh, you can parameterize how its behavior, so its stiffness using this tab. So in this you have in the various models like Hookean spring, and also if you want to parameterize your own uh, characteristics, you can also add a model over here. So the stiffness mode, there are again two options: characteristic value and 1D lookup table. So as similar to the other things, you can also add these values over here, and the amplification factor is also it has the same definition as the other tabs. Okay, so you can do this for both the front and rear axles. So in case that your team's design doesn't have the stabilizer bar or a anti-roll bar, so what you can do is that just specify this as 0. So going on to kinematics. Yeah, I'll just like to add one more thing. So like as like we are in the like we just started into the manufacturing phase. So in case like if such kind of situations happen that you want to add a stabilizer bar, so you can also verify your decision. So like or validate your decision using the stabilizer bar model, and you can see how does the vehicle perform, and you can take the decisions accordingly so that like it is a safe it is zero risk decision or a less risky decision. So yeah, going on to kinematics. So Yeah, so before we start kinematics and compliance, I'll just like to brief the teams about what is kinematics and compliance. So kinematics describes the spatial movements of a wheel due to compression and steer action. So there are two cases of kinematics, like distinguished cases of kinematics, which are suspension kinematics due to pure wheel compression, which occurs due to pure wheel compression, and steering kinematics, which occurs due to pure steer actions. Okay, so in reality, the superimposition of both these isolated cases exists. Okay, so and yeah, so we'll just go back to kinematics in a bit. I'll just brief you about what is compliance also. So compliance describes the spatial movements of a wheel due to wheel forces which cause elastic deformations of the wheel suspension. Okay, so let's go to the reference manual for this, for the user's guide for this. Okay. Yeah. So, like as I mentioned, so the kinematics is dependent upon wheel travel as well as the steering characteristics. Okay, so what do I mean by steering characteristics? What do I mean by wheel travel? So basically, like uh, there are three types of kinematic models that are available in IPG carmaker. So which are linear 1 DOF, linear 2 degrees of freedom, and linear 3 degrees of freedom model. So basically, like the linear 1 DOF model is the model in which kinematics depends only on wheel travel. So basically, you can only parameterize the wheel travel. In linear 2DF model, so kinematics depends on wheel travel as well as the steering rack displacement. So the effects of both these things uh, can be uh, uh, can be seen. And in linear 3DF model, so the all the three the wheel travel as well as steering rack displacement are considered. Along with this, the movement of opposite side wheel is also considered in kinematics. Okay. So like one more thing that like to just tell about the importance of user's guide and reference manual. So in this also you will see the axle tab, axle column is there. So this is a extremely important column in which it is mentioned that where can you use this model. So for example, like just like select the linear 1 DOF and it is given as rare. So like if we think, okay, why is it that only linear 1 DOF model is applicable to the rare axle? So just let's go back to the carmaker GUI. Okay, so let's go to the rare axle, and in this, okay, 1 DOF model is available. So as I mentioned, so like in 1 DOF only the wheel travel is considered. So as like in Baha vehicles, so you don't have any steering system in the rear on the rear axle. So there is no need to model the steering rack displacement properties, or there's no need to include that. So you can use this linear 1 DOF model to model your rear suspension as well. Okay. You can also see that this linear 1 DOF model isn't available in the front system because like we have because in the front it is a pre-default thing that there will be a steering system. Yeah. So yeah, so the compression tab over here is basically the is used to parameterize the wheel travel. The steer tab is used to parameterize the steering rack displacement. Okay. So in linear 3D, you will be able to see the opposite wheel travel tab also. Okay, so you can parameterize these values also over here. Okay. So now, like, just to gain more insights regarding this, like, which values should be added over here? So let's go to the IPG carmaker guidelines. Okay. So in this, you'll be able to see what all values should be mentioned in which tabs. So for example, in rotation RX, so camber angle should be mentioned. In rotation RY, the caster angle should be mentioned. So do refer the this part in IPG guidelines that have been provided by BAHA. So in which will give you more insights regarding how to parameterize your vehicle, and it will reduce your time rather than just experimenting. So now that we have covered all this, so let's see the other options that are available in kinematics. Okay, so let's select this SKC file. So the SKC file is created using a external software or a external software package that is used that is created by IPG only, which is called as IPG kinematics. So IPG kinematics is a program system designed to simulate a vehicle axle on an axle kinematics test bench. Okay, so it is a virtual test bench which can be used to calculate kinematics, steering kinematics, and elastokinematics of the suspension. Okay, so to go into the kinematics tab, so just click open kinematics, IPG kinematics over here, and from here you can create your SKC file. Okay, so create a new model, just go on to new model and you can select from any of the type of suspension that you want. So we'll cover this section tomorrow. So we'll have IPG kinematics covered in depth tomorrow's session. Okay. Right now I'll just exit this. Okay. So now, okay, so now that we have also seen SKC, let's go to MBS. Okay. So MBS, so what is MBS? So basically, the this option is used to model a high resolution multi-body system suspension for both front and the rear axle. So gain more information regarding this. Let's go to the user guide, sorry, the reference manual for once. Okay. So this is the MBS suspension section in the reference manual. So in this, you can see that as I mentioned, so this is an external MBS file that is going to be inputted into the vehicle dataset. Okay, so what is actually happening behind the scene is that from the vehicle model, various parameters are being inputted to the vehicle suspension model, such as the forces and torques to the vehicle carrier center, the forces on the force elements like spring and damper, and in return as an output, the MBS suspension model is giving wheel carrier motion due to kinematics and compliance and etc. So you can understand the model in much more depth using the reference manual and referring to MBS suspension section. So now let's go back to the. So now let's to open the MBS editor, you just need to select on this. So now that we have entered the MBS G1, okay, suspension dataset G1. Okay, so in this, you'll be able to see like various tabs are there. So like to parameterize different sections of a suspension system. Okay, so like to start with, like you can select the suspension model, whichever is specific to your design. So in Baha, a lot of teams use a double wishbone in the front. So like I'll just select double wishbone axle over here. So then moving on to the calculation mode. So there are two calculation modes available over here. So dynamic and accelerated. So you can select whichever one you want. So this will affect the resolution of the results that have been provided that have been created by the MBS file. Okay, so you can read more about this from the user guide. Okay, so now coming on to this tab, which is with steering system. Okay, so let's see, like I'll just unclick this. So as you can see, the graphic image that is there in the bottom of this window. So over here, you can easily visualize what are different components that are there in the model and which uh, parts of which, like, is it a joint or a bushing? So basically a bushing is made by a blue color and a joint is referred by a white color. So like as I mentioned, so you can use like you can model the steering system with this. So if we click this, so you can model the effects of the steering rack displacement on the on the suspension using this. So now, like the next thing is symmetrical suspension. So symmetrical suspension, as the name suggests, so it signifies that the suspension is symmetrical about the center axis, or on the like basically the right side and the left side are symmetrical. So you can just select or unselect this based upon your designs. And yeah, so let's go on to bodies. So in this, like as I have selected the symmetrical suspension tab, so you can see the only the left side parameters can be parameterized. The same values will occur in the right side. Just going before to body, so like I'll like to add one thing. So normally, as the teams are now in the manufacturing phase, so like even if, for example, a team has designed a suspension system that is symmetrical, but uh, what if that system isn't like manufactured to that accuracy, which is pretty like common thing, like in like considering the setups that the colleges have. So ensure that you should also like see like the vehicle models which are manufactured and compare those parameters while inputting into this. So for example, if you have a symmetrical suspension and you are selecting over here, well and good, there is no issues. But if you don't have, and you, even though you're just basing like basic like designing the model based upon the CAD inputs, the CAD model. So in this, what will happen is that we have also have a validation event at the main side, main physical side in the phase 3. So in that, what will happen is that even if your vehicle performed in a pretty good manner in the virtual tracks in the phase 2, the vehicle might not perform to that accuracy in the validation event. So again, and once the vehicle model is submitted, you can't do anything about that. And validation event also has pretty good points, so you'll lose your competitiveness as a team over there. So just ensure that you parameterize your model as accurately as you can, and you just don't manipulate uh, values to have a better vehicle, because validation event is also important as good as this the virtual dynamic event. Okay. So moving on to bodies. So in bodies, you can specify the masses and the moment of inertia over here. So you can see use the graphic tab to see which parameters you are parameterizing right now. So which components you are parameterizing right now. Okay, so let's close this and go. Let's go on to joints. So basically, like the coordinates of all the hard points of of the suspension elements besides spring and damper. So basically, you don't need to include your spring and damper elements. So basically, you don't need to include the hard points of your spring as well as the damper system. In this, you can include rest all the other hard points over here. Okay. So similarly, you need to enter the hard points in this, and you can visualize this using the graphic button. Okay. Moving on to the force elements. So over here also, so as I mentioned, in joints, we are excluding spring and damper elements. So now coming on to the force element, we are just adding the hard points of the spring and the damper element. Okay, so over here, we can mention those values. Okay. So now the next part that is there in force element is that spring. Where is the spring? Where is the damper? Where is the stabilizer mounted? Okay. So in this, you can choose where your spring, damper, and the stabilizer have been mounted using this uh, option. So either a lower zone or wheel carrier. So basically, the teams which are normally the rear wheel drive, the teams which have a rear wheel drive vehicle. So what they do is the damper is mounted at the lower wishbone. So you can choose lower wishbone over here, so that like according to your design. So now, like what if there is an you have your the spring or a damper mounted on the upper wishbone. So in this, you can't you are not able to see that option, right? So for that, you can go into you will need to create a SKC file or a file via IPG kinematics, in which we can mount the spring as well as damper on the upper wishbone. So which will be, I guess, much more required for the all-wheel drive teams. Yeah. So having explored this, let's go to bushings. Okay, so like bushings, the parameters of for all the bushings of wheel suspension are entered in the bushings tab over here. So various bushings that are part of the suspension system has been can be chosen using the left sidebar over here. So basically, you can parameterize your the bushing that is used in the lower wishbone front left using this by just selecting this. Same for the other things as well. Okay, so you can add the positions of the bushings using these, and it is important to refer to the bushing axis system. So like I'll just go into the user guide. Okay. Okay. So in this, you can see the bushing access system. So as each and every team is using the bushing, okay, so you'll need to parameterize this. So it is only the level of up to which accuracy you are uh, parameterizing your bushings. But then also you'll need to ensure that the positions of the bushes are accurate. Okay. So for that, you can refer to this section. In this, you can see like the bushing position and the orientation have been mentioned. Over here, a thing to notice is that this is a FR suspension frame. So frame suspension. So the thing that the reason why I wanted to come in the bushing access system is that you need to model your bushing access system according your bushing positions according to the frame suspension, okay, which is a different frame, okay, than FR1 or some other frame. Okay, so basically the FR suspension frame is the like just imagine the front track width. You're seeing the vehicle from the front view. The FR suspension, the center of the FR suspension frame will be at the center of the track width when you're seeing the system from the front, okay, from the front view. Okay, so just ensure that you are adding the parameters according to the relevant suspension frame. So let's go back to GUI. Oh, sorry, the MBA setting. Okay. So now, like if you can also add the stiffness mode for all the three directions and the torque value for the torque. So like using characteristic value or one day lookup tables. This is similar to the things that we have seen earlier. You can just parameters this using those values. Okay. Similarly, damping can also be parameterized. On to the mapping. So in mapping, so you see like this number of grid points tab over like option over here. So basically, number of grid points option is just used to increase or decrease the resolution of your model. Okay, so like you can select anything based upon your requirements. So in this, you can add the various parameters that have been mentioned in kinematics and compliance. So like these will be, I guess, easily available to you guys. So maximum compression, maximum steering rack level. So you can add these values from the from your design. Okay, so now going on to the miscellaneous tab. So in this, you can add the camber angle as well as the toe angle, and you can add a description over here, like if you want to, like for example, so this is a double wishbone. That's it. Okay, so you can add any description like this. so that you can remember which model you have created, or if you have tuned the model. So like data management is extremely critical in virtual dynamics. So as you will do a lot of iterations to optimize the performance, so just ensure that you give proper descriptions to your models so that you can save time like that, and you will be able to identify the right model that you need to input. Okay. So now that we have created the model, just go to file and save it. So I can just add this. I just add demo. Okay, close this tab. So now that we have created our MBS file, so I will just go to model and open. Over here, you can see the demo.mbs file is available. You can just select and OK, and the file will be created. Okay. So I guess there were a few doubts. Aditya, are there any questions? I just saw a few people had raised their hands.
Okay, so yeah, there are two people have raised the hand, so you can post your questions in the Q&A section. Since we have to still cover a majority of the part of the vehicle dataset or parameterization, we'll cover all your questions in the Q&A section, but we'll ensure that all the questions get addressed. Okay. Also, another point I would like to mention here, Ruturaj, if you can open the MBS editor once. Yes, if you can go into the bodies section. Yeah, so as you can see, you have mentioned all the mass properties here. So even if the mass properties here, what are mentioned are used just for calculation purposes, but these are not directly included in your actual vehicle file. So even if you have mentioned if you have mentioned these here, these are just for calculation purposes. In your body section, you still have to include all these masses. So just make a quick note of that. Yes, Ruturaj, you can go ahead.
Yeah, so
And yeah, so this point is similarly applicable for the SKC or the IPG kinematics file as well. So the masses which you will be entering in either in MBS package or your kinematics package, both are just used for calculation purposes. Uh, like, but you have to mention all the masses or the aggregate mass in the body section of the main vehicle dataset window. Okay, so just make a note of this point. Okay, Ruturaj, you can go ahead.
coming back into the vehicle dataset, so let's go to compliance. So like right now you see that this is disabled. The option is disabled for the front axle, whereas it is enabled for the rear axle. So like you can choose a model from this. So why is that? So basically, like as you have chosen a non-linear model, like over here in the kinematics, due to which like you can't model compliance for that axle. So and in the rear axle, you have just chosen the linear one way of model. So if you want to model like uh, the MBS as well as SKC files uh, have inherently calculate the compliance as well. So just there is a thing to note. So just don't get confused over there that okay, like there is no other option is disabled over here. Okay. So in like, there are various options available over here. So like linear frame FR1 and linear frame FR2. So like you can explore regarding this using the guidelines. I'll just go to the user guidelines. Okay, yeah. So you can explore the linear compliance models using the user guide. So all the information regarding linear frame FR1, linear frame FR2 has been described over here. And we have already gone through what is the definition of compliance and kinematics. So you can relate that things to the models as well. So moving on to the next thing. So wheel bearing. So in this, like you can parameterize the wheel bearing friction. both in the front and the rear axle. So if you just take this option, you can add the friction coefficient, bearing radius, and amplification values. Right now, I'm just going to untick this. Coming on to external forces. So like external suspension forces interface is designed for specific applications such as adaptive suspension systems. So and like which are like kind of semi-active systems kind of. Okay, so at this interface, forces calculated by the external model can be added to the spring, damper, buffer, or stabilizer forces calculated by the car maker. So basically, the like up till now we have just parameterized the various elements based upon inertias, majorly, and like the spring and the damper element. So if you want to add additional forces to that as well, you can do that using this model. So in this, there are two things: separated components and like by default, not specified is a single model in which like the external forces can be added as a whole to the entire force elements, and in separated components model, you'll add a different model, different forces to different force elements. Okay, so you can explore, teams can explore this. Yeah, but like you can keep it as not specified for the final submission. Onto steering. So, the steering system like consists of a mechanical model which defines the ratio between the steering wheel angle or the steering wheel torque, okay, and the steering rack displacement. Okay, so basically, like there are two kinds of models that are available in uh, IPG car makers. So, which are like steer by torque model and steer by angle model. So you can choose whichever is relevant for you, whichever whose data is available to you guys. For example, the static steer ratio model is the model in which you can parameterize the based upon the angle, and in a dynamic steer ratio model, you can parameterize based upon the uh, torque, the wheel torque. Okay, so in yeah. So in this, you can add. So I'll just go back to static shear ratio. Okay, so in this, like you can add this parameters using a characteristic value mode or a 1D lookup table mode, which has two options: the ratio as well as rack travel. So you can add these values according to your design. Okay, so going on to the dynamic steer ratio option. So in this, an additional mechanical model tab is unlocked. So in this, as I mentioned, so this is a model in which this is a steer by torque model. So in this, you also need to add these inertia parameters, then rotational damping, and all these things. So you can add these according to your design. Okay, so besides this, there is also the power steering model, which is available in steering. So as Baha vehicles don't use power steering, so you can there's no need to like use this. So you can choose between the static steer ratio and the dynamic steer ratio models. Okay. Going on to tires. So like the tires, we have added the guidelines regarding how to create tires in IPG last year's guidelines. So, IPG guidelines. Open them. Yeah. So in IPG car maker guidelines 2022, we can see the tire section and refer this to create your own tire model. Okay. So so there is this option that you can select it from the available ones, like the examples that are available in the uh, like in the model itself, or like product examples can be also chosen. So various models are given by IPG by default. So you can either go use these, or you can just select anyone, and you can also edit. So for example, if you have created the model and you want to parameterize it, so like if you want to change it, so what you can do is just go to edit, and you will see that tire data set HUI, and in this you can parameterize your tire using various parameters. Okay, so like you can explore this in detail via the IPG guidelines that have been provided to the teams. Also, like you can explore this using the reference manuals and user guide. So for now, I'm just going to select. So moving on to brakes. So in brakes, uh, okay, just I forgot to mention one thing. Yeah. So as I like Aditya had was specifying a lot on how to adjust this mass in body section. Okay. So like in steerings, like you need to be extremely vigilant while parameterizing the steering system. So if you choose the dynamic steer ratio option, so in this you're adding the inertia values as well as the mass values of the steering system over here only. So you will need to ensure that you don't add it again over here. Okay, so like it is an iterative, it is a thing of just like verify, like you need to just validate that uh, if the mass and inertia properties are being added in the steering system, there is no need to add that separately again into the body strap. Okay, but if it is a static steer ratio model, so in this there is no this you can't parameterize the mass as well as the inertia value. So you in this scenario you'll need to add it in the bodies. Okay, so you need to be vigilant over here, and as Aditya said that just again and like just to verify that you have an accurate model, at least in terms of the mass. You can just go again and again to the assembly tab and see the overall mass. Let's go to brakes once again. Okay, so uh, yeah, so in brakes, so like you can choose like either the hydraulic model or you can add your own model. So as like various teams use hydraulic models, so we can go ahead with this only. Okay, so in this, the first tab is general. So in this, the brake torque amplification axle should be mentioned over here. So in Baha, like a lot of teams also use brake biasing. So you can also parameterize those values using these amplification factors over here. Okay, for the front and the rear axle. Okay. Going on to the control section. So in this, you have modes like hydraulic basic control and then the HI. So the hydraulic basic control, you can choose the option that you want from over here. So and in that you can also model the regenerative braking using different modes. So like no regeneration, parallel or serial. So we'll cover the regeneration part in the EBA section. So right now we'll just focus on MBA and we'll cover that tomorrow in tomorrow's session. Okay. So yeah, moving on to the system. So yeah, now that we are in the systems tab, so uh, brakes that has been that is modeled in IPG car maker is a S split system. Okay, so teams need to make sure that you are know this if like because as there are various different types. Like for example, if you're using cutting brakes, so you need to you need to know that this is an S split model that has been parameterized by default in the IPG car maker. So in such kind of scenarios, you will need to add a model using MATLAB Simulink or C code plugin. So I'll just show you the illustration regarding this. The reference manual. Okay. So in this, you can see how pressure distribution the hydraulic brake system is taking place in IPG car maker. So in this, like it is actuated either by force, so the pedal force, or by the position of the brake pedal, which has been given by the driver, and from there the pressure is created into the cylinder master cylinder, which has been transferred to the wheels in the form of torque, braking torque. Okay, so this is a S split system. So please make sure that you know this. So in this, like after you've chosen the pressure distribution model, you can again choose the mode by which you want to actuate your system. So as I had already mentioned in the reference manual, so it is either actuated by the brake pedal force or position. So you can choose the relevant model that you want using this option. So either pedal actuation or pedal force. Based upon this, you can there are different parameters that you need to input, and so you can get more information regarding that to the user's guide. So in this, yeah. So in this, both the models have been described. The description for both the modes has been told over here. So just refer the user's guide to gain more information regarding this. Back to the carmaker GUI. In this, like also the parameters like response time and build up time can also be referred using user guide. Okay. Uh, so these values, so you will also need to parameterize the pressure to brake torque and park brake torque at the wheel values for both front and rear wheels. Okay. On to powertrain. Okay. So
Just before we move on to the powertrain part, like I'm seeing just one of the hands raised, which is still pending. So you can just post your question in the Q&A section. We'll cover that in like after the vehicle data set parameterization is complete. Okay. Yes, Rudraj, you can go ahead.
okay. So yeah, so now that we are in powertrain, so one thing that like I have already mentioned this, like you need to refer the latest IPG car maker guidelines that Baha will provide you this season as well. So, for like especially in powertrain modeling. Okay, so like you need to ensure that because various values, for example, like the weight of engine. So if you see the guidelines of 2021 and 2022, the weight of the engine has been changed. So in 2021 it was 23, that was the default value, but in 2022 it was changed to 27. So like a lot of default parameters get added into the new version of the guidelines. So just make sure that, especially during powertrain parameterization, you have your IPG car maker guidelines with you and you are thorough with the powertrain section in the IPG car maker guidelines. Okay. Okay. So like for powertrain, so there are various models that are available. Okay. But like if so there are only two models that can be chosen by Baha team, so which are conventional or the electrical ones. So as the rest of the things are not valid to the powertrain models that are available in Baha. So for like as I said that we'll be covering the e-bar section tomorrow. So you can like in that we'll explore the electrical section, electrical model. So right now I'll just select with the conventional model for MBA powertrain. Okay. So in this in the general tab you can see various the information regarding your the entire powertrain model at a glance. So basically which is the gearbox, which is the clutch that has been used, You can see all this information at a glance, and you don't need to go into each and tab, so which will make which will save a lot of your time. Okay, so besides this, you'll also see this graphic illustration over here, in which if you can directly click, so basically the orange uh, cylinder block is the engine. So I'll just click on this, and you can directly go into the drive source, that is an engine. So just like you can also use such kind of things, like shortcuts basically, rather than going to each tab. Okay, so now that we are in drive source and under engine, so in engine you need to ensure that you are using the values that have been mentioned in carmaker IPG guidelines as default over here. Okay, so the values of inertia as well as engine off speed, engine idle speed, torque ignition off has been mentioned in the guidelines. So ensure that you are using the same values over here also. So just okay. So yeah, so these default values should be used in the general type of engine. Now, like there's one more thing that ensure that you are choosing the crankshaft orientation as y-axis. Okay. Uh, so on to the torque. So in this, by default, you need to choose 2D lookup table, and in this you need to add the mapping model, and in this you will need to add the rotational speed, throttle position, and the torque values for the engine. Okay, so like, in the last year's guideline, you can see that there is a link to an Excel sheet which provides this data set. So just like make sure that you like refer to this year's uh, link or to this year's values. Okay, I already opened these values. So this is the lookup table. Okay, so what I'll do is I'll just delete it and copy it over here. Okay, so now we have added the gym parameters over here. So just ensure that these values are, as the engine model is same for each and every team. So you need to ensure that you are using these values only. So otherwise, like uh, these values have been mentioned in the guidance. So you need to ensure that you are using these values only. Okay. So moving on to fuel consumption. So in this, as mentioned in the guidelines, you need to just click the checkbox and leave all the values at default. Okay. So just ensure that you are just checking this, because if you don't do that, there might be an error in the simulation. Okay. On to turbocharger. So keep this as unchecked. The turbocharger option as unchecked, and leave all the things as default. Okay. So on to intake, similar to turbocharger, untick the intake manifold pressure option over here. So moving on to bodies. So we have already parameterized the engine mass and the inertias while adding the body in the assembly tab. So you can just ensure these values once and that these values are correct once again over here. Let's move on to starter motor. So like like as specified in the guidelines, IPG carmaker guidelines, you need to keep this as default. Okay. Both the tabs should be kept as default. So now coming on to clutch. Okay. So like there are various clutch models that are available in IPG carmaker, but like as majority of the teams use a CVT. Okay, so if you are using a CVT, you need to use the friction type of model. So this is specified by IPG carmaker only. So you need to ensure that you are using the friction type of model. Okay. So in this, you need to parameterize the inertia in and inertia out values. You can find the information regarding this using the user guide. Also, the definitions of position connect and disconnect can also be found using the user's guide. So in maximum torque, just ensure that you're keeping the maximum torque from engine as 19.2 and multiplying that by the CVT ratio. Okay, if you are using a CVT, just keep this as default. Yeah. Okay. So yeah, also you need to specify the friction slope. Going on to torsional spring. In this, you have two options to model the torsional spring of the clutch, which are characteristic value and bundle lookup table. So in this, you can add the angle versus the torque values according to your spring characteristics, and you can specify it over here. Okay. On to the gearbox. As I had already mentioned earlier, that gearbox in you need to make sure that the gearbox in IPG car maker is your continuously variable transmission. Please don't select any other type of gearbox over here. Just don't consider that you're selecting like we normally are used to referring the two-stage reduction gearbox as the gearbox. So don't select that over here. Okay. So yeah, I've already chosen the continuously variable transmission over here. So if if the team is using some other type of system, so like for example, if the team is using a manual transmission, you can also choose a manual option model over here. Okay. On to gears. In gears tab, you can model the various torque loss ratios for different CVT ratio. Okay, CVT transmission ratios. Okay, so basically, like in the general tab, first you need to import the this like the minimum and the maximum ratio values and the build up time from minimum to maximum. So basically, like build up time in over here like is the time that is required for the CVT to shift out from the maximum ratio to the minimum ratio. Okay, so just ensure that you add these values according to the guidelines. Okay. You can't use like add. You can't manipulate these values. Okay, so you can also change the number of ratios based upon your uh, requirement. So if I'm changing it to 3, so you can see that I need to parameterize only 3 ratios for torque loss ratio. Okay, just leave it as 5 only. So in this, now you can add what are these 5 ratios. Okay, that we have added over here. You can specify those values. Going on to the ratio 1. So in this, you need to specify torque loss ratio. Okay, so the torque loss represents the friction effects on the gearbox depending upon the input torque and the input rotation speed. So basically, uh, this torque loss is going over here, like what we are considering under torque loss is the effects uh, is occurring due to the torque loss is occurring due to the friction effects that are prevalent in the gearbox. Okay, so ensure that you are parameterizing the torque loss ratio according to that, and you need to also input the torque and the rotational speed values. Okay, uh, so also ensure that you have negative torques initially rather than zero. So similarly, you need to model the other ratios as well. Going on to bodies, in this you need to specify the mass as well as the inertia of the gearbox. Okay, so I'm assuming that like let's say 4 kilos, the weight of CVT is 4 kilos. So you can specify that mass and the inertia properties over here. Going on to tank, in this you can parameterize the weights of the fuel tank. So you can refer the values of last year right now, but refer the latest values that have been provided this year. and parameterize the inertia accordingly. Okay. Also, just to verify that these values have been registered in the assembly tab, just go to assembly parameters and check whether these parameters have been added over here. Okay. That we have done with powertrain drive source. Okay. In driveline, so now like coming on to driveline. So there are like as I mentioned earlier, so like we are using gearbox, the CVT as our gearbox. Okay. So all the rest of the transmission ratios will be included in the driveline. Okay, so for example, like the driveline over here is all the things that connect the gearbox to the wheels. So all the things that come in between. So like for example, like the drive shafts as well as the differential like, and etc. So all these things will be parameterized in the driveline tab. So over here you have various models available, which are like front drive, rear drive, etc. So you can choose the model that based upon which is the driven axle that you are using. Okay. So as like I'll just choose all-wheel drive right now. Going into the front axle. Okay. So there are different coupling models that are available for the differentials. So like viscoelastic, torque sensing, torque vectoring locked by DVS. So to understand more regarding this, what you can do is you can refer the user's guide. So in this table, you can find the description of each and every model that exists in the differential coupling model. Okay. So in this also like interesting or a useful column is basically the differential position, which can help you to understand that where you need to use such kind of a differential also. Okay, such kind of a coupling model. Also, like one thing that I like to suggest the team is that to ensure that you read these things also. So, like this is the tips that have been provided by IPG itself on how to choose the correct differential model. Okay, so like for example, like let's say that the team is using a two-stage reduction gearbox or a two-stage basically a two-stage reduction gearbox in the rear. So like what kind of a coupling model will you choose? So for that, you need to choose the locked model for as the coupling model. So in this, you can see the description as well. So this coupling model acts like a rigid connection between the input and the output shaft. Okay. So besides this, other models can also be chosen based upon what kind of a differential model you are using. Okay. Let's go back to the GUI. Yeah. In this, there are various options that are available. So let's explore viscoelastic. So what is it? A description of viscoelastic? It is like basically a differential locking system with hydromatic converter. As soon as the rotation, as soon as the as soon as there is rotational speed difference between both output shafts, a part of the torque is transferred from shaft which rotates faster to the shaft which rotates slower. Okay. So, like based upon this description, okay, let's explore the viscoelastic coupling model. Okay, so in this, like these things are going to be like the first five parameters are going to be pretty much same for all the coupling models, which are inertia in, inertia out, inertia cage, transmission, and efficiency. Okay, so inertias, like I have mentioned, what is inertias, the previous that I have covered. So, like let's just focus on transmission and efficiency. So, transmission is basically the transmission ratio that the differential is having. Okay? And efficiency is the like powertrain efficiency basically. Okay? So, yeah. You can keep this efficiency as one. Okay. Okay, so now also you need to specify the friction coefficient over here. You can gain more information regarding this from the guideline, the user guide as well as the IPG guideline. Okay. So in this you can see like so there is a mounting tab. So basically left to right, input to left, and input to right. So based upon the orientation in which your differential is mounted, you need to select this mounting option. Okay. Right now I'm going to just choose left to right because like I'm considering that like it is transferring the power in lateral directions. Okay. Now coming on to the option that is there for coupling rod. Okay, so in this, as you saw that like based upon speed difference, the torque will vary for the viscoelastic coupling model that we have read in the that we had read in the description of the model. So in this, you need to specify the speed difference and the torque values. Okay, based upon that, you need to parameterize this, and based upon which the coupling model will act in your vehicle. So similarly, you can model the rear axle as well as diff center. So a thing that you'll see over here is that flexible driveline option. So if you click on this, so you'll see, let's go to rear axle. Okay. So in this, in the drive shaft tab, you will see like the flexible half shaft and flexible drive shaft option has been unlocked. So the flexible driveline option can be used to parameterize the stiffness and damping characteristics of the half shaft as well as the drive shaft. So if you have the values of these accurate values of these parameters, like you can use them as well. But like I'm just like mentioning this once again, just ensure that you don't add like random values or just theoretically calculated values over here, because it can like the rigid model will give much more better results in comparison to this model, okay, if the values aren't accurate. So let's untick this for now and go on to power supply. So like in like power supply isn't relevant to the MBA powertrain systems that are used at the powertrain systems that are used in the MBA vehicles. So basically you can leave this as default. Okay. Then coming on to the control unit. So in the diagram also you can see, so the like on the uh, uh, topmost branch of the this kind of illustration, there is powertrain control. Okay, so powertrain control is the system that is going to like that is going to decide what values of what transmission values need to be inputted right now, or what uh, like torque values need to be inputted right now. So I'll just go dive more deep into this. So just a minute. So like, so for example, like we'll start with TCU so that it is pretty easily understandable. Okay. So as we have chosen the so TCU, TCU is the abbreviation of transmission control unit. So the transmission that we have chosen is auto continuously variable transmission. Okay. So in this, uh, there are two control modes: single track and speed envelope. Okay, so I'll just go to speed envelope once. Okay. So in this, you can see that you can parameterize the rotational speed of the transmission based upon the throttle percentage and the velocity of the vehicle. Okay, so I just go to the user guides. Okay, so like I have selected the speed envelope right now. Okay, speed envelope mode right now. So the desired rotational speed is selected depending upon the current vehicle speed and the gas pedal position. So like you can parameterize these values, and like basically the TCU will give these values. For example, if the driver is giving the input of throttle, a throttle input of 1 basically. So basically he has the throttle input 1 is basically that he has pushed the accelerator pedal up till the throttle, the pedal stopper that is there in our vehicle. So in that, so there are these different velocity values that there are there for throttle 1 value. Okay, so for example, if the velocity of the vehicle at that instant is 55, so then the rotational speed of at the output of the transmission system will be 5000. Okay, so you can use this for tuning the CVT. Okay, so you can choose the values according to your tuning calculations and input this values over here. Okay, so besides this, there is also a single track option available. So single track option is used in a situation where you like minimum fuel consumption is required. Okay, so just go back to the user's guide. Okay, so desired rotation speed corresponds to the engine operation point with minimum fuel consumption for the current power demand. So if you want to go for the minimum fuel consumption, you can choose the single track option. Okay. And this you'll need to add the minimum rotational speed. Yeah. Besides this, you will need you can also like parameterize the grip control and the brake limit. You can get more information regarding this through the user's guide. Okay. So I hope that like you have an idea about what is a control unit. Okay. So similar to this, so this is the PT control unit. Okay. So in this, the PT control unit, it determines the target values for the control units. So basically the target value for target torque for the engine. Okay, so based upon the inputs from the vehicle control and the current driving situation. So as I mentioned, so we'll explore that section tomorrow. So there is a like you can parameterize how the driver is going to give inputs regarding the like the gas pedal inputs as well as the clutch pedal inputs. So based upon that, in that the gas pedal inputs will control the torque over here. So now specify at which gas pedal value what torque should be provided by the engine. You can choose this model. You need to parameterize this. Okay, so in this go just choose the generic model. So as other models aren't relevant to MBA, it is also mentioned in the guidelines to choose a generic model. So now, also one thing that you need to notice over here, that just click the start engine with button option. Okay, so this is also mentioned in the guidelines. Okay, so now you can click on you can tick mark the gas interpreter option. This you can there are two more. So characteristic value as well as one-day lookup table. So and 2D lookup. Sorry, there are more than two options. So basically, 2D lookup table as well as DV. So like in characteristic value, you can add the maximum torque at full gas and minimum torque at zero gas. Okay, so as I mentioned, so like we are controlling the what is the torque output based upon the gas pedal position. Okay, so like let's go to one day lookup table so that you will be able to visualize this much more better way. So in this, you can you can add the maximum and the minimum values over here, and then you can parameterize the torque based upon the gas pedal positions. Okay, you can find more information regarding this into the user's guide. Yeah, so after this, like uh, like coming on to ECU. So in the ECU, you need to keep this as uh, the model as default. So ECU is basically engine control unit. Okay. So now coming on to we have already covered TCUs, which is transmission control unit. We'll cover MCU. So MCU is basically motor control unit. So as the Embraer powertrain doesn't consist of a motor, so you can keep this as default. And similarly, this is the battery control unit. So keep this as not specified, as there isn't a battery that is a drive source for the powertrain. Okay. So yeah, now that like we have covered the entire powertrain parameterization. So I'm repeating this once again. So just ensure that we are referring to the values, especially while powertrain modeling. Like we are referring to the values that have been mentioned into the IPG carmaker guidelines, because there are uh, like as I mentioned, so you need to you need to use a lot of things by default, which have been provided by Baha only. Okay, so now we have completed the powertrain model. So now we'll go to the sensors. So I had earlier mentioned this. So basically, you need to add these at the during the final vehicle submission. So guidelines regarding this will be launched during the final vehicle submission. So you can refer those and get the sensors. So as ATS team also mentioned, so vehicle control app is used for driver assistance system. So this isn't relevant to bar, so you can keep this as default. And also you need to show this won't affect the vehicle performance or vehicle model in any ways. Okay. So that's it. So we have covered the entire vehicle data set. So as you can see that there is a lot of importance that the reference frames have, the coordinates have, or the positions of each and every component have. So you need to make sure that, like at least initially, you have a properly model full CAD vehicle assembly. As I'm expecting that as the preliminary round of the phase one has finished, so most of the teams will have such kind of models. So you need to ensure that in the initial modeling phase, you need to input those values accurately in IPG car maker, like and ensuring that the reference frames are taken into consideration. If you make even a slight mistakes in understanding the reference frames, the model won't be accurate. And in the later on stages, so like once your vehicle has been manufactured, you have the actual dimensions of the vehicle as well. So at that time, you need to focus more towards the validation event as well. So right now you can just like explore the software and explore the maneuvers part, the driver part, the scenario editor part, and like and parameter is just not focus much more on the vehicle data set. And in the later stages, just ensure that you are using as many parameters that are there on the manufactured vehicle are entered into the IPG car maker. So because it will hamper your performance in the validation event. Okay, so just don't uh, manipulate the values, considering that it won't affect us in the we'll have a good vehicle for the virtual event, but in validation का देख लेंगे. So ऐसे मत करो. Just ensure that you are using the parameters accurately. Besides this, also like as like in the suspensions or like while even powertrain also, we have mentioned like what kind of things that you can do. So for example, the clutch. So in the torsional spring tab, you can specify the spring constant. So for example, you are in the phase of designing the new torsional spring for your CVT, the secondary clutch. So you can take the make use of this IPG carmaker software and derive what are the uh, what would be the optimum spring constant that we need to manufacture. Okay, so your design life cycle or the risk that you are taking while manufacturing each and every component will be reduced if you be smart and use IPG car maker to your benefit. And also like this will ensure that you are also wasting less amount of money, because as we are like as if you is a competition for collegiate clubs. So money is always going to be a problem. So the financial side is always going to be tough. So just ensure that you don't take a lot of risk and you use IPG car maker to make more accurate decisions. Up to you. Like I'm handing over the mic to you. Yes.
Yes, thank you, Ruturaj. That was a comprehensive session, like consisting of all the parameterization of all the sub-assemblies and assemblies. So I hope the teams you have got a good enough idea of how to go ahead with your vehicle parameterization. So today we have covered, so before we move on to the Q&A section, so we have covered a majority of the aspects of IPG carmaker with like both the ATS team as well as the Bahal SA India team. But try to take this training session as an opportunity to learn and get started with your virtual vehicle environment. So the takeaways for today would be like to leverage this training session and utilize it like to for the virtual dynamic event. So that would be one. Moving ahead, and you have gained a good insight into the concurrent industry simulation practices. So that is one of the a very important aspect which we have, which is a very good takeaway. So moving ahead, like before we before coming tomorrow, so we would expect you to at least go ahead today and make a virtual vehicle, and you have a virtual vehicle ready by tomorrow, at least so that you can follow through the entire process of simulation, which is focused for tomorrow, so that you don't have to go ahead after that and like you have to do both the aspects. So simulation will be covering in detail, and to follow through all the fields which will be showing, so you need to have a understanding of how your car is parameterized. So, and how your car is parameterized and how good fidelity model you have already with you. So the least would which you could do is make a vehicle using vehicle data set generator. So at least try to do that using the values from the rule book or the previous year's bias India like IPG car maker guidelines. So that would be the thing. Secondly, um, you can start with creating a high fidelity model for this year's vehicle. So throughout the session we have tried to highlight it wherever possible. For instance, in be it in suspension, powertrain. So the highlight or focus was given on creating a high fidelity model. That is because to navigate this year's track, you will need that model to like follow through the entire track or course while clearing the obstacles. And having that high fidelity model will not ensure, because the ensuring part will come tomorrow, but it will at least help you to get started with this year's track. And it can follow the tight turns and whatever or however difficult obstacles are thrown at you. Yeah, so a few points I would like to reiterate here once again. We have tried to include, like we have reiterated a few points earlier too, but one thing I would like to say here is since like at the end of the session, you have seen that the IPG car maker has like modular parameterization. That is, everything is parameterized in different sections. Like for instance, for powertrain, it is modeled in different section. For suspension, it is in different. So ensure that you don't add any redundant masses. That is adding a same mass twice. So just make sure that at the end of your vehicle parameterization, you have the entire vehicle mass, which is similar to what is of your real vehicle, physical vehicle, and similar to what you have designed like before getting started with the virtual vehicle model. So you must have a target weight which you must have defined. So try to get it as close to that as possible. So just make sure that you don't add any redundant masses. Yeah, and one of the good resource to check that would be the info tab in the vehicle data set. Okay. Yeah, so moving on, we'll like take the we'll proceed with the Q&A section. So if you have any queries, you can post it like in the Q&A field below. So we have addressed a few queries earlier. So I'll just go ahead and see which are not covered yet. Okay, so there is a question regarding, I guess, in compression, do we need to add the change? So I guess this is from the linear section of the suspension kinematics.